421 national disaster events recorded worldwide in the year 2022. Among the most damaging are tropical cyclones, what the World Health Organization would refer to as typhoons or hurricanes. As damaging as the wind can be, the greatest damage to life and property is not from the wind, but from secondary events such as storm surges, flooding, landslides, and tornadoes. To combat and prepare for these events, world leaders and local governments try to anticipate early warning signs in advance of the event using satellite, radar, and other advanced technologies. Despite their best efforts, these disasters happen. When they do, communities are affected and the damage can be extensive. According to the National Oceanic and Atmospheric Administration in the United States, 2023 was the most expensive year on record for billion-dollar climate disasters. What are the towns and municipalities to do? This is where smart cities come in. How could microchip technology help bring smart cities to life? Let's go beyond the microchip and hear a story of empowering innovation to enhance the human experience. Our guest today is Alan J. Zwirin. Alan is a senior product marketing manager at Microchip Technology, working out of the Power over Ethernet business unit. He joins us from our global headquarters in Chandler, Arizona. Welcome, Alan.
Thank you. Glad to be here.
Thanks for joining us on Behind the Microchip. In the intro, we briefly talked about the impact natural disasters have on local communities and the rise of smart cities. What can you tell us about that?
So in the Power over Ethernet business unit, we're kind of unique because we actually build devices out of the silicon that we produce. And one of the devices is called a midspan, which comes after a switch to put power on the line. And we also build an outdoor switch. When we build outdoor midspans and switches, we make sure that they are IP66, IP67 qualified. That means that you can take a fire hose or a monsoon rain and you can direct it at the unit and it will continue to function. IP67 is much more unique, and that is because it can actually be submerged for a limited period of time and still continue to function. That means when you are placing devices outdoors for security or for public safety, for public use, if you use some of our technology to power that, the power will continue to function to the device and enable the device to function in all conditions.
And that's to make sure that communications are not severed and that information can get to the areas that are affected by a flood or a storm surge or a heavy rain, right?
Yes. As a matter of fact, that's a perfect example. New Orleans, Katrina, a perfect example of that. What happens is you want to be able to have security cameras. It's a tourist destination. You also want to be able to have Wi-Fi available to everybody. But how are you going to ensure that works if the area starts to flood? It's important for the police to be able to access those cameras. Well, in New Orleans, we deployed a whole bunch of outdoor switches. And what happens is these switches have 4 PoE ports. And one of the PoE ports can be used for a radio to receive. So it will continue to function, receive and transmit data. And then the rest are usually connected to cameras, and sometimes a port is connected to a wireless access point. The cameras can be accessed and show the officials what are going on. And wireless access is actually very important because if you're stuck in the middle of a flood, you're on a roof somewhere, you want to be able to get to somebody like the police. And by having that wireless access, you can start messaging people and telling them where you are.
That way authorities and emergency services can get to you.
Right? Exactly. We all saw the pictures of the boats during Katrina going to people on the roof. Well, to make that happen, you need to have service. And if cell towers are knocked out, you still have the backup having the wireless that can survive.
So we're not unfamiliar with flooding out here in the desert. We're in Chandler, Arizona, which is in southeast Phoenix, right outside the metropolitan area. And every summer we get what we refer to as our monsoon season, which means it's very hot, it's very dry and very dusty until a gigantic storm system moves through, dumps a ton of water, washes everything away, and we basically go back to our lives. But in that moment when the deluge hits, that's when you want to have something that's, all intents and purposes, waterproof, would you say, at least for a temporary amount of time?
Definitely. And that's what IP67 means. IP67 means it can be submerged for a limited period of time while that water is surging. I'm also very familiar. I come from the Middle East. Mm-hmm. And what happens there is there's one rainy season. When it rains, rivers emerge out of nothing. They're called wadis. Mm-hmm. And what you will see is you will see the river coming towards you. And unless you have a device that can withstand that river coming, passing, and then receding in a few hours, you will knock out all of your safety backup.
And the benefit of this is that it's entirely sealed, right?
Yeah. So the way that we make our units is very, very unique. First of all, there are very few people who make outdoor units, midspans and switches. As a matter of fact, we introduced the first outdoor switch in 2018. We just introduced our most recent switch, a second generation switch, this past April. And the way that we approached it was, number one, we wanted it to be of a smaller size. So a lot of times you'll see these big boxes hanging off of poles. Those are outdoor enclosures where you're putting an indoor unit in or a hardened unit in, and those usually fail. But the second thing is we wanted to make it so that it could withstand any environment. So what we did was we made the entire box out of a composite metal, and that composite metal acts as the heat sink passively, and it makes it much smaller. And what we did was we sealed the entire thing. There are many units that you can open and close. When you open and close a unit, you're compromising the seal. Also, if you can open and close a unit, people can tamper with it. Mm-hmm. Our units are tamper-proof. And you can put it up on on a pole, on a building, and it will continue to work. We have a story from a customer who is a wireless internet service provider, and they would go and they started by using these outdoor enclosures. They're called NEMA boxes, right? And they're very good at protecting from the element. But they would take one of these hardened units, they'd put it in a NEMA box. It takes up a lot more space, and then they would attempt to deploy their wireless internet service to an urban area. What inevitably ended up happening was that the ones in the NEMA boxes always failed. They then started using our outdoor switches, and he told me they never fail. They're very, very reliable. So even if something is going on, weather-wise, environment-wise, he can continue to deliver internet to his subscribers. And nobody wants their internet to go down.
Ever. So you said it's encased in a composite metal, and that's obviously for heat dissipation, but that would probably add a layer of durability.
It's a funny story. I was just at a conference, and somebody comes up and looks at our switch, and he said, "Boy, that even looks bulletproof." One of the original product managers actually heard that at a previous conference. So he said, I never thought about that. So he took it back to the office. He took it in the back, and he actually put it on a pole, and he shot at it. And at least that one was bulletproof. I don't know what caliber he used and how far away, but it was very, very solid design.
You know what they say, one test is worth 1,000 expert opinions.
That is very, very true.
Okay, so you mentioned New Orleans a little bit earlier, a city almost synonymous with hurricanes due to the devastation of Hurricane Katrina back in 2005. And this was a previous generation technology. Is that correct? You talked about the first one brought to market?
Yeah, so originally we brought the first outdoor switch to market in 2018. At that time, the 802.3 BT standard, which enables up to 90 watts of power on an Ethernet cable, was not ratified. So What we did was we built a box, but it was called pre-BT. Before the BT standard was adopted, everybody was using a pre-BT standard. So we produced a box pre-BT. It worked for a number of years. Then the BT standard was ratified, and our second box came out with BT standard. Interestingly, we offer something called MPoE or multi-PoE. On our chips, we actually have firmware that will recognize if the request being made from the device is a BT request or a pre-BT request, and we will service it in the manner that it was requested. And by the way, that's one of the nice things about power over internet. It's a very safe power because it will not deliver power to the unit unless the unit requests it. And if the unit doesn't need power anymore, it will stop sending power. And when the request is made, it only sends the amount of power that was requested.
Let's talk about quality of life, which is a big theme here at Beyond the Microchip. And we talk about enhancing the human experience. One global constant, I think, other than death, taxes, and weather, is motor vehicle traffic. And I'd venture to guess that some people would rather pay taxes than sit in traffic. So you think this technology has implications for reducing traffic during peak hours?
So that's a very, very interesting question. One of the most, I would say, one of the most unique applications that we've had using our technology is powering outdoor RFID readers. There's a deployment in London where in downtown London during work hours, if you go down there, you are assessed a toll, a tax. The reason for that is in your car. If you go down there in your car, you're assessed a tax or a toll. The reason for that is they want to limit the amount of traffic to improve the quality of life, to improve the air quality down there. So what they've done is they've deployed RFID readers on the streets, and it's all powered by our Microchip's power over Ethernet switches. And so by that way, they are working at improving the quality of life. But quality of life has a number of, facets to it. Safety is a big one. And New Orleans, in several major cities, we have actually deployed cameras throughout to watch and try to prevent crime. One of the things in the city of New Orleans does is they use it to look at license plates to see if there is somebody who they are looking for or who shouldn't be there so that they can respond immediately. And you think about it, New Orleans is a tourist destination. In order for the tourists to feel secure, they want to make sure that the police presence is felt. And by having cameras down there, they can identify and even preempt crime before it happens. But it's not only about security, though security is a big thing. Whenever people are gathered, you want to make sure it's a safe environment. Many arenas around the world have used our multi-port PoE midspans to go in to add cameras to their arenas. We're talking arenas that deploy 2,000 to 5,000 cameras so that they can ensure the safety of everybody during the event.
Large sporting events, right?
Exactly. We've done a lot of that. We've also done it in airports. People want to make sure that they're safe in airports. Dallas-Fort Worth Airport, fully wired up, it has cameras throughout the entire airport, all powered by Microchip power over Ethernet. But as I was saying, it's not only about security. You also, I don't know anywhere you go where you don't see people working on their phones. And nobody wants to work on their phone just using their cellular data. They want to be able to work on their phones connected to a wireless access point. So many cities have begun to offer free Wi-Fi internet, ubiquitous internet through wireless access. And that is another huge application for quality of life. As a matter of fact, we just completed working with a Big Ten university that was wiring up their 36,000 acre campus, I think between undergraduate and graduate, something around 50,000 students, that they can offer Wi-Fi not only in the buildings, but anywhere where the student is walking. And that has a safety aspect to it. If something's going on, they can ask for help, but also has a quality of life aspect to it.
Access to information.
They can access it wherever they want, whether it's about school or just getting on social media.
So we've been talking about cities, and you just mentioned a college campus. These are somewhat densely populated areas. What about any less populated or remote areas?
So very interesting. One of the big applications is for wireless internet service providers. If you don't know what that is a ISP sending services, not by putting copper in the ground, not by putting fiber in the ground, but by sending a radio signal, receiving, and then communicating through that radio signal. It actually started in Laramie, Colorado, or maybe it started in the West, in rural areas. Rural areas were very underserviced with this. So what they did was they set up a transmission radio and a receiving radio that could talk back and forth. And then in the rural area, they then distribute the signal locally so that farmers, for example, can have full internet access. This started with one little co-op. Today, there are almost 3,000 wireless internet service providers in North America. I was just at a show for wireless internet service providers. There were people from Europe there. There were two people from New Zealand there. This is a very popular thing. And today, it's not only in rural areas, it's into hard to reach places. A lot of inner cities don't have great internet service. This is a way to get internet service to hard to reach places. So it's now becoming very common, not only in rural areas, but in suburban areas, in inner city urban areas. It's an excellent solution, all powered by Power over Ethernet.
While we're talking about Power over Ethernet, as a technology, we've kind of talked about the benefits of what Power over Ethernet can provide. But why is Power over Ethernet? Why does it exist? You've got other methods of transmitting power, but Ethernet is typically associated with data rates, right?
So first of all, you've got to understand where this came from. Back in the 1990s, a major IP phone manufacturer, and IP phones were just coming out, wanted to power their phone the same way that the telephone companies power their phone. If you've ever noticed, if there's a blackout in your neighborhood and your phone is connected directly, it still works. The reason it still works is because the power is provided over that RJ11 jack that you have from the phone company. Well, the IP phone manufacturers did not want to have to plug in their phone. They wanted it from the Ethernet cable that was coming to their phone. So they approached us. We were at that time known as Power Design. Power Design was acquired by Microsemi. Microsemi was acquired by Microchip. But interestingly, most of the same people are still there today. And what happened was they asked, can we make such a thing? So we invented two things. We invented a power source equipment IC, and then we also invented a powered device IC. The power source equipment IC puts the power on the line. The powered device takes the power off the line, puts it into the device. But in 1997, when we came out with this, there were no powered switches. So the next thing we did was we used our power source equipment chip to go in and to provide power after a switch. So you take from the switch, you go to the midspan, it injects power on the line, and then it goes off. So that was the origin of it. But then what started happening was it started to become a standard. We work with the IEEE. We made the first standard. We contributed over 70% of the documentation, and people started using it. And why did people start using it? There are many reasons. First of all, it's safe power. even today, with the BT standard up to 90 watts, it's considered class 2 power. Mm-hmm. Class 2 power is under 100 watts. It is safe power. It is safe power even if it was constant power on the line, but it's even safer because no power goes on the line until the device requests it. It is an international standard, so it's the same all around the world. And it's not based on one plug in Asia and a different plug in North America and a different plug in Europe. And of course, Australia has to have their plug too. It's one plug. It's an RJ45 jack, and it comes through it. Because it's safe power, you don't need electricians to run it. So it is less expensive to deploy. That's another reason why people do it. And if you run a line one place and then you need to run it someplace else, again, no conduits are needed, no electricians are needed. So it's easily flexible and scalable. So those are the big reasons why people are looking at it. But if we start to look at the future, we see that most of the devices in our homes are actually powered by DC. So we're bringing AC to the home, and on every plug, we're putting an AC to DC converter. And what happens is that is going to create power loss along every single conversion. So what's beginning to happen is there was a new electricity standard just introduced. It's called Class 4 fault managed power. So to travel over long lines, AC is still the best.
Right.
But then when you get to the house or you get to the building, people are beginning to convert it to Class 4 fault managed power 1 conversion. Class 4 fault managed power is basically pulsed DC power. Again, it's a safe power also. And then at the end, we simply take that and we make it into PoE and we power the devices. And in a lot of retrofits that are happening today, there's a big hotel down in Texas. We are seeing this scheme, and it's much more efficient. You're only doing 1 conversion energy loss, and it is helping to power, it's helping to power the entire building.
Yeah, so we were joking about this off mic about all the different powers they have, because UK's got to have one, Australia's got to have one, East Asia's got to have one, and what you're looking at is this odd little mixture of shapes and holes to be able to accommodate every single plug imaginable. And then you look at your basic Cat 5 or Cat 6 Ethernet cable, which is the RJ45 jack.
Yep.
All the same.
All the same everywhere you go. Much, much simpler.
Yeah.
You know, when you travel, I do a lot of international travel. And of course, you have to have an adapter for every different place that you travel.
Yep.
My briefcase probably weighs about 10 pounds, about 22 kilo. And, half of that, I think, is made up of adapters that I have to carry with me everywhere I go.
I have one big universal adapter that's about the size of a baseball.
Yeah, I have that one too. But, you have a phone, you have a tablet, you have a PC, a razor, maybe an electric razor you're traveling with. You have a few devices. Yeah, you need more than one, unfortunately.
It'd be nice to have one standard. Well, so we have one standard, but it would be nice to expand that. So which devices specifically are we talking about today? We had a previous device you talked about in 2018, but we have an actual device we want to talk about today.
So today, what we're focusing on mostly, we do have outdoor midspans, which will inject power, but our outdoor switch is very, very unique. The outdoor switch is called the PDS 204 GCO for people who like numbers and letters. And what that does is, by the way, that was developed giving the feedback from our first switch. Mm-hmm. And so it's a totally sealed unit, as all of our units on. A very strong metal casing, again, maybe bulletproof even, tamper-proof. The seal is something that the way that we put the plate on is with attachments that can't be opened except with a very special tool. And it has 4 PoE ports, and it has 2 fiber ports. And the 2 fiber ports are the key, because you can take and run from an indoor source a couple of kilometers and get data to the switch outdoors. Once you have that data to the switch outdoors, you can use the second port to forward information to a next switch and a next switch and a next switch. So you can do daisy chaining with this. And then what's really nice about this is if you return back to the original source, if there's a break in any of those fibers, the system will automatically find the route back to the source and continue to function.
Good for redundancy.
It's very good for redundancy for failover.
Okay, so suppose one of our listeners has a use case for this technology, either what we've been speaking about or based on your descriptions, they've thought of something novel. Where would they go and how could they adopt it?
So the first place they should go is to microchip.com/POE.
Okay.
On it, they will see a section for systems, and they'll look at the systems. And the basic questions you've got to ask is, what are you powering? And the reason we ask that is based upon our experience, we'll give different recommendations. The second thing is, how much power do you need? And that will determine what unit you need based upon the standards. And the third thing is you ask, what is the environment you're going to deploy it in? And lastly, do you need a single unit, a single port, or do you need multiple ports? Once we have all those, we can easily determine for you what are the best recommendations.
So we know what it is, we know what the value is, we know where to get it. Do you have any predictions for the future of PoE and how this technology could enhance the human experience, like examples we talked about today? Where's this technology going?
So I think that this class 4 power that we're seeing, that's in very, very early stages of adoption. I think we're going to see a lot more of that. Again, the energy efficiency of that is a very key factor, and the safety is a very key factor. But in order to do that, what we have to also see is more and more things being powered by power over Ethernet. And the original 3 devices that were the most popular, still probably today, were IP phones, IP cameras, and wireless access points. However, today, there are literally hundreds of things that can be powered by power over Ethernet. And I think that's where we're going to see changes, is we're going to see more and more devices powered by power over Ethernet. You can buy computers today that are powered over Ethernet. You can buy printers today that are powered over Ethernet, TVs, all these things. But there are some devices that are going to require more power. And either a refrigerator, we're never going to be able to power by power over Ethernet. But there are interesting things. This hotel that I was talking about in Dallas that was all retrofitted for PoE, an iron takes an awful lot of power. But an iron sits 99% of the time in your hotel room without doing anything. So they've redesigned the iron to be powered by power over Ethernet by having a huge battery charged up, ready to be used through power over Ethernet.
So we're going beyond computer peripherals now.
Way beyond computer peripherals. If you take a look at IoT, there are 2 requirements, I think. 1, it has to be connected somehow. And 2, it has to need an exchange of data. And the third thing is it needs power to power it up. Whether it's a disconnected device that you put onto a charger and then maybe download some data, or it's a connected device, any of these can use power over Ethernet. And we're talking about, thousands, if not more, of devices that I think are going to be enabled to power over Ethernet over time. We're sitting in a room, it has a sensor in it for the lights to go off. That's powered by power over Ethernet. Thermostats. We did a nice little coffee break with Ross, and we showed just the devices today that could be powered with it. Lighting is a very popular one that's coming on. So we're seeing it emerge in all of the IoT areas.
I mean, how many things need more than 90 watts?
Very few. Very few. Things with big motors, washing machines, dryers, refrigerators. Beyond that, they don't need it. And all of this is going to power over Ethernet.
This is wonderful, Alan. Do you have any final thoughts you want to share?
I think that's the hardest question of all. But as I look at it, I think what we're going to see is there's going to be more and more demand for power over time, and we have to make it more efficient. Class 4 is an example of trying to reduce the power request load through energy conversion efficiency. I think as more power is needed over time, the more devices we have, we're going to have to get much more efficient. And I see, even though power over Ethernet was maybe considered a little dated technology invented in 1997, I see it becoming more and more popular each and every day.
Yeah, if it's efficient and accessible.
Yes.
Alan J. Zwerin is a senior product manager at Microchip Technology. He specializes in power over Ethernet and related technologies. He joins us today from our global headquarters in Chandler, Arizona. Thanks for joining us, Alan.
Thank you. And if people want to find out more, they can see on LinkedIn. I have several articles on that, and they can always contact me through LinkedIn, and I'm happy to help them with any of their needs.
It's wonderful. We'll also post links to the Power over Ethernet solutions on our show notes page.
Excellent. Thank you for inviting me.
Thank you for venturing beyond the microchip with us. Join us next time as we continue to explore empowering innovation to enhance the human experience.